Okay, section 9.2 is going to be an introduction, or hopefully a review of some information that you've learned about circles in the past. There's some substantial vocabulary, so make sure you're paying attention to the vocabulary when you've done your reading. You're reading pages 370 through 371, a whopping 2 pages of reading. And then there's some sample problems that follow. So do your reading and then come on back. Okay, first of all, we talked earlier in the year about our definition for a circle and the difference between the definition for a circle as from a sphere. And both a sphere and a circle have what's called a center point. We define a circle to be the set of all points equidistant from a given point in a plane, whereas for a sphere consists of the set of all points in 3 dimensions that are equidistant from a given point. So first of all, make sure we understand our definitions for a circle and for a sphere. Now, for a circle, and we're going to focus in on circles now. Spheres will follow in a few chapters. But for a circle right now, what you've learned in the past is you've got the distance around a circle, which is called the circumference of a circle. And you learn 2 formulas, which we are going to have kind of as postulates. We're not proving them yet. 2 formulas that give us the length around a circle. In other words, if an ant were to start here at point A and the ant were to walk all the way around the circle and come back to where he started from, that would be the length that the ant has traveled, and we refer to that as the circumference of a circle. You had 2 formulas. You had circumference was 2 pi r, and you had circumference was pi times diameter. Note that 2r equals d, because here's a radius, and a diameter consists of 2 radii, so they're really the same formula. So on our circle, we want to be able to talk about stuff related to a circle. The first thing we've mentioned is a circle has a center, which I will call O. It's a point. And if I have 2 points on a circle, say A and B, I could talk about 2 what are called arcs. And an arc extends from one point on a circle to another point and includes all the points in between. You should notice then that there are 2 arcs here associated with points A, B. There's this arc that I've drawn, which is less than half of a circle, and there's this arc also over here, which is more than half a circle. So we're going to talk about minor arcs, those are less than half a circle, and major arcs, which are more than half a circle, and a special arc, which is exactly half a circle, is called a semicircle. So to name a major arc, what we want to do is add a 3rd letter in between. So if I give you a minor arc, CD here, arc CD, to talk about this other arc around here, pick a letter, another letter that's in between, or add one yourself, and you want to talk about major arcs always with 3 letters, C, Y, D. And the letter in the middle goes in the middle when you name the major arc. Minor arcs are named with 2 letters, the 2 endpoints of the arcs. Arcs have 2 things. Arcs have lengths, so they are portions of the circumference, and arcs have measures. An arc's measure is the degree measure, defined to be the degree measure of the central angle that is associated with the arc. For example, if I give you this circle and I tell you here's arc CD, what is its measure? Its measure is going to be the measure of the angle formed by drawing radii to the endpoints of the arc, and that angle measurement in there is the measure of the arc. The length of the arc is going to be a portion of the circumference. So if I tell you, for example, that the radius of the circle below is 4, and I tell you the measure of angle COD is 60 degrees, I would say the measure of arc CD equals 60, whereas the length of arc CD is going to be a portion of the circumference. Well, the portion of the circumference, there are 60 degrees in that central angle, so it's 63/60ths of the entire circle. That's what I'm going to have here. So that's going to be 1/6 of the entire circumference, which is 2 pi times r, which is 4. So that means then I would have 4/3 pi would be the length of arc CD. Next we have sectors. If I've got a circle, a sector of a circle consists of an area, it's a region, and it's bounded by 2 radii and an arc. So in other words, a sector of a circle is like a slice of pizza from a round, traditionally cut pizza. Chords. Chords are segments associated with a circle, and we're going to learn a whole bunch of types of segments or lines associated with a circle. For now, we're going to talk about chords. And chords simply run from a point on the circle to a second set of the circle, and at the endpoints, that segment formed, its endpoints lie on the circle, and it passes through the circle. That's called a chord. We have a special type of chord. If a chord passes through the center of a circle, that special chord is called a diameter. We also have upcoming in a future chapter, we're going to look at what's called a segment of a circle, and that kind of seems a contradiction. A segment of a circle is a region that's bounded by a chord of the circle and an arc. So that's called a segment of a circle. And when we do area in the future, we're going to be interested in finding areas of segments. Finally, last bit of vocabulary for now associated with circles. I give you a circle, and I've got an angle whose vertex lies on the circle, and each ray that forms the angle passes through and intercepts the circle in exactly 1 point. That angle there is called an inscribed angle of the circle. And we'll learn about other types of angles associated with circles depending on where the vertex of the angle falls. But for right now, we're going to look at just inscribed angles. And again, if you have a point on a circle and you draw 2 rays to form the angle, and the rays intersect the circle in exactly 1 point, that angle is called an inscribed angle.